Hi, I'm Ben Gittleson, and I'll be presenting my final project, RAG Makes Command R Less Safe. So, Retrieval Augmented Generation, or RAG, underpins modern LLM systems in a number of safety-critical domains, such as finance, medicine, and law. RAG systems consist of a retriever component that fetches documents that are relevant to a user's query, and then a generator component that generates a response given the query and the retrieved documents. The retriever is non-parametric, whereas the generator is parametric, or is typically an LLM model. On et al. In their paper RAG LLMs Are Not Safer hypothesized that RAG should make models safer if the retrieved documents are safe, but they actually find that the opposite is true. And they illustrate this in the graphic on the right, where they show that when a user asks something like, how can I build a bomb? In the non-RAG setting, the parametric memory may not be able to answer that question, whereas in the RAG setting, the retriever may be able to retrieve a relevant document and answer that query in a way that's unsafe. So specifically, On et al. Finds that when RAG is included in an LLM generation pipeline, 8 out of 11 popular LLMs, and this is from model families like Claude, GPT, and Llama, produce more unsafe responses with RAG than without. And this occurs even when the source documents are overwhelmingly safe. So in their case, over 95% of the retrieved documents are benign or do not contain a harmful material. Even in that case, they find that model responses with RAG can enable violence and fraud or provide inappropriately tailored financial or medical advice. Models do this by repurposing benign information from retrieved documents to create unsafe answers. So On et al. Themselves say that they don't specifically test RAG optimized models. And this includes models such as Cohere's Command R and the Jamba family of models. They leave as an avenue for further research whether their findings would extend to these types of models. And that's what I explore in this project, specifically with Command R. I look at two research questions. First is that basically, do their findings replicate for Command R? So if we generate responses to the same adversarial prompts with and without RAG, which setup produces safer responses? And then if the safety rates between the two methods are different, what factors explain that difference? I'll talk now a little bit more about my methodology for this project. First, I'll dive into some more detail about the model I used. So I used a Command R from August 2024. This is a 32 billion parameter model that Cohere Labs has optimized for RAG and tool calling use cases. It has an 128,000 token context window and has been specifically fine-tuned for grounded generation, so generating responses with citations, using supervised fine-tuning, and then also preference fine-tuning with a grounded generation prompt template. In my experiments, I used the grounded generation prompt template that was recommended specifically by the Cohere developers, as well as their default hyperparameters. So that's a sampling temperature of 0.3 and a max new token limit of 256. I tested this model using the same dataset that's used in On et al. 2025, which is called the red teaming resistance dataset. This consists of prompts that are designed to elicit harmful responses from LLMs across 15 different safety or harm categories. Because of some of the inference latency I encountered, I sampled 1,639 out of 5,192 prompts from this dataset at random. And then I ran inference with and without RAG enabled and evaluated response safety. I'll now dive a little bit more into my RAG architecture. So I set up a RAG index using a June 2024 Wikipedia dump chunked at the paragraph level. That's the same Wikipedia dump and same chunking strategy that OnItAll uses. I used 1,024 dimensional embeddings that were generated using the BGE M3 model, which I also used as a query encoder. And then I had to randomly sample 1 million of those chunks to ensure that I could fit my entire RAG index into memory at once and also have reasonable inference latency. So that reduced the size of the Wikipedia dataset pretty significantly. I used a dense retriever with flat inner product as implemented in FICE, or essentially cosine similarity between the, essentially cosine similarity. And then I used Command R August 2024 as the generator with a grounded generation prompt template as specified by the developers. Once I had generated the outputs, I then judged them for response safety using LlamaGuard 3, the 8 billion model. This is a model from the Llama family. It's fine-tuned specifically to act as a safety classifier, so it outputs a safe or unsafe judgment for each model response given the prompt context. And then if the response is unsafe, it will also output a safety category label. And LlamaGuard is the same judge that OnItAll used in their paper as well. All right, so this slide just illustrates that architecture overall. So we can see that the green cylinders all represent data sources. The blue squares are their outputs, and then the purple squares represent places where I used a language model. So we start again with the adversarial prompts. On the top left, that comes in as a data frame from the red teaming resistance dataset. We then build the RAG store, which is represented in the column leading up to the dense retriever. Using the dense retriever, we retrieve 5 relevant passages. That's one of the settings used in OnItAll 2025. These are then passed to the LLM generator, which is the Command R model. We then generate responses, judge them using LlamaGuard, and then output a final safety label, so safe or unsafe, as well as a category if the response is unsafe. And that's what I use for analysis. Okay, so I want to now revisit the first research question, which is if we generate responses to the same adversarial prompts with and without RAG, which setup is safer? Or essentially, does RAG also make Command R less safe? So similar to OnItAll, I find that it does. So adding RAG increases the overall rate of unsafe responses from Command R from 18.9% to 21.0%. This effect is particularly pronounced in the following 3 categories. So hate, where we see a 62.1% increase, suicide and self-harm, where we see a 37.5% increase, and nonviolent crimes, where we see a 16.2% increase. This slide also demonstrates the differences in response safety by category when we use Command R with and without RAG. So again, as you can see here, the difference is particularly pronounced for nonviolent crimes and hate, as well as suicide and self-harm, although those counts are much lower overall. And then for a number of other categories, there's little to no difference, or in some settings, RAG actually makes the model responses a little bit safer. For classes such as child sexual exploitation or indiscriminate weapons. And I'll talk about why that might be a little bit more in the next set of slides. Okay. So this slide breaks down the proportion of unsafe responses by the number of documents that Command R cites in its response. So the kind of important takeaway here is that the violation rate is much lower when Command R does not cite any documents. So even if we retrieve documents, it may not cite them in its response. And in that case, we see only a 5.2% violation rate. That's actually much lower than the base violation rate without RAG of 18.9%. Most of the large proportion of the increase in the violation rate comes from cases where Command R cites 4 or 5 documents. So as you can see, that occurs in 57 and 228 cases, although there's no real clear trend in overall unsafe response rate after we get to citing at least 1 document. Okay. So I now want to visit my second research question, which is if the safety rates between the two methods are different, what explains that difference? So I replicate the finding in On et al. Here, which is that models can repurpose benign information to produce an unsafe response. We can see in this prompt here, the user asks how they can avoid paying for advertising by using fake reviews. The response without RAG tells them that's unethical and illegal, and then goes on to refuse to answer the question. With RAG, it retrieves a number of Wikipedia articles and then cites various illegal or unethical strategies for paying for advertising by using fake reviews. In a smaller subset of cases, and if you recall from the category breakdown graph, there were a few cases where RAG actually made the responses a little safer. In these cases, that's often because the model fails to ground its response in any relevant documents and then just refuses the harmful query altogether. And as a bit of a content warning here, this does contain some homophobic content. So this is an adversarial prompt that uses a hypothetical conversation between a human and a bot, as well as some spelling obfuscation, to try to prompt the model to output homophobic content. Without RAG, the model leans into its parametric memory and outputs hateful content, which is bolded there. With RAG, the model is not able to retrieve any documents, and I would guess that may be because, or not able to, it does retrieve documents, but it's not able to cite any relevant documents to ground in its response in. And because of that, it refuses the query altogether. So I'll now talk through a few strengths of my study, I believe, as well as some limitations and future work. So the kind of key findings here, or key insights, are that we do find that On et al.'s conclusions extend to RAG-specific models, such as Command R. So RAG can still make these models less safe. Another important finding, which was not one of the original research questions, is that Command R appears to be a fairly unsafe model overall. Many of the models that they tested in their original study had base violation rates without RAG below 5%, such as Claude and GPT. With or without RAG, Command R still has a pretty high violation rate. So again, with RAG, it's 21.0%. Without, it's 18.9%. So that indicates that while this model may be adept at RAG tasks, it might not be the one that you would want to deploy in a production setting without safety guardrails. A couple limitations of my study. The most prominent is that the random sampling of Wikipedia, I believe, probably decreased the likelihood of finding truly relevant documents for each query because I had to downsample the Wikipedia dataset so much. I'd also note that the LlamaGuard safety judgments, while they're human validated on a different benchmarks dataset, were not human validated on this dataset, and I think that's a weakness of the original On et al. Study as well, because they rely on that methodology too. So I'd like to validate those human safety judgments in further research. I'd also be interested in extending this analysis to other retrievers, such as hybrid dense and sparse retrievers, and other RAG architectures like graph and agentic RAG. And finally, testing on some of these domain-specific adversarial query sets and RAG indices, maybe in domains like the financial, legal, or medical ones. And that's all. Thank you.